All right, so we're going to finish off 6.4 today, and then after that is 6.5, and then after that we're going to have a quiz on 6.3 to 6.5. So 6.3, we dealt with our domain and range, so that's going to be on your next quiz, as well as what we've learned on this stuff, on functions, and then when we get to 6.5. Jensen, do you have the chapter 6 book? Okay, it is beside you there. Right, so we're going to finish off 6.4 today. I think it's just one day on 6.5. I will confirm that later, though. And then will be 6.3 to 6.5 quiz. After that, then we'll be going into chapter 7. And then after chapter 7 will be our next test. So we started looking at functions last class. What is a function? And when you do have a function, you can write it using function notation. So we've got this relation y equals 3x minus 1. To write it in function notation, remember function notation has the letter f in there, which stands for function. And you've got a variable, a letter inside the bracket. And that letter will match whatever letter is in the equation, whatever variable is in the equation. In this case, the variable x is inside the equation. So we would say f at x, because x is the variable in the equation. So instead of y equals 3x minus 1, we say f at x equals 3x minus 1, which means that f is a function of x. So there is the answer to part A. We've written it using function notation. Part B wants us to use a table of values. We always start with the independent variable first. We choose different values for x, and that'll give us our values for y or f at x. And we can use whatever values we want for x, so I'm going to use these 5 values. But we could use whatever numbers we want. When x is negative 2, 3 times negative 2 is negative 6, take away 1 is negative 7. And you can do these on your calculator. The calculator will do order of operations for you. So there's 3 times negative 2 minus 1. You'll get negative 7. When x is negative 1, 3 times negative 1 is negative 3. Take away 1 is negative 4. When x is 0, 3 times 0 is 0. Take away 1 is negative 1. When x is 1, 3 times 1 is 3. Take away 1 is 2. When x is 2, 3 times 2 is 6. Take away 1 is 5. Remember, we learned about linear versus nonlinear relations. We said if you have an equation, you can look at it and know whether it's linear or nonlinear by seeing if there's any powers. There's no powers here. That makes it linear. We also said that when you're looking at a table of values, you can tell if it's linear or nonlinear by seeing if as x changes at a constant rate, y also changes at a constant rate. So I chose values of x that increase by 1. The values of y are increasing by 3. That pattern is there. Looking at this table of values, that's how you would know that it's linear. But we also knew that from the equation. There were no powers, which makes it linear as well. So we've got our table of values. Now it asks us to graph the function. So let's draw our axes in there. And maybe I'll just move this over so it's kind of more in the middle. If we put the points, the first point is negative 2 comma negative 7 is down there. Negative 1, negative 4 is there. 0, negative 1. If x is 0, you don't go left or right, but you go down 1 unit. 1 comma 2 and 2 comma 5. All these points line up, and because we started with an equation, whenever you have an equation, that means the data is continuous. You can put fractions in for x and you'll get an answer for y. You can put decimals in for x and you'll get an answer for y. This is continuous data, which means you can draw a line going through all of the points because it's continuous data. So there's a line for that relation. Then it asks us in part C, determine the value of x if f at x equals 53. So again, we have the equation in function notation that f at x equals 3x minus 1. Question C asks us to find the value of x if f at x equals 53. So f at x is this entire expression to the left of the equal sign. That is 53. We want to know what x is. By adding 1 to both sides, you'll get 54 on the left, and then dividing both sides by 3. So you're going to get a decimal for this. When you go 54 divided by 3, actually you don't get a decimal. It's an integer. The answer is 18. You got this copied down, Jensen? You're on the right page? No, you're not. You don't have the right book. The third pile. Yes. Because this is block 3. See my little system? You see what I have to deal with on a daily basis in my job? One of these days I'm going to lose it. I might lose it on Keen. Okay, so there's the answer. On the next page. So again, you're given a function in function notation. G at x is 3x minus 4. The first question says find g at 3. So if you compare that to g at x, the difference is instead of having an x in the bracket, you have a 3. The x is replaced with 3. So in the equation, we replace the x with the number 3. And then we work it out by following order of operations, which says we multiply first. 3 times 3 is 9, and then we subtract and get 9 minus 4, which is 5. There's your answer. G at 3 is 5. G at 3 is asking, what is the value of the function when x equals 3? That's what G at 3 means. And so G at negative 2 then means what is the value of the function when x equals negative 2? So we let x equal negative 2 in the equation and we work it out. 3 times negative 2 is negative 6, and negative 6 take away 4 is negative 10. There's your answer. G at negative 2 is asking, what is the value of the function when x equals negative 2? And so G at 2/3 is asking, what is the value of the function when x equals 2/3? So it'll be 3 times 2/3 minus 4. And you can do this by making the 3 a fraction, because obviously 2/3 is a fraction. When you multiply two fractions together, it's top times top, bottom times bottom. But the 3's will also cancel. Multiplying by 3 and then dividing by 3 changes nothing. So what do I mean by that? Well, if you start with a number, let's say the number 5, if you multiply by 3 and then divide it by 3, we started with the number 5. 5 times 3 is 15, and then 15 divided by 3 is 5. You've got the number you started with. When you multiply by a number and then divide by that same value, it doesn't change the original number. So that's, whoops, I don't want to do that. Let's cancel that. I just want to get rid of this page. There we go. So that's why I said when I multiply by 3 and divide by 3, it changes nothing. I'm left with the number 2. And 2 minus 4 is negative 2. Now you also could have done this on your calculator. We could have taken the number 3 and then multiply by, in brackets, 2 over 3. There's 2/3. You still get the number 2. if you use the calculator. Okay? So either way, 3 times 2/3 is 2, and then 2 take away 4 is -2. Then part D says, what is the value of x if all of g at x equals 11? Again, we're starting with the original expression that g at x equals 3x minus 4. There's those first 3 questions above, we were given a different value of x every time. We wanted to find g at 3, so what is the value of the function when x equals 3? Then we found g at -2. What is the value of the function when x equals -2? This is saying that g at x, which is the entire left side of the equation, is 11. We want to find out what x is. That's what it says. What is the value of x such that g at x equals 11? So you let g at x on the left equal 11. You've got the 3x minus 4 on the right. You need to solve for x, which we would start by adding 4 to both sides. On the left side, 11 and 4 gives us 15, equals on the right side, the 4's cancel. To get x by itself, you would divide both sides by 3. 15 divided by 3 is 5, so x equals 5. And you could check this. We wanted to find what value of x would you put into the equation so that g at x equals 11. So again, here's g at x. We're saying that if x equals 5, this equation should work out to 11, and it does, because 3 times 5 is 15, and 15 take away 4 is 11. So it checks. 5 is a number that when you put it in for x, you get an answer. You get g at x equal 11. So these questions, very similar, except the only difference in this case is that the equation has a squared in it. We're told that a at t, a is a function of t because the variable in the equation is the letter t. A at t equals t squared, take away 3. So to find a at 2, you're going to let t equal 2. Whatever t is, you square it. 2 squared is 4, and 4 take away 3 is 1. When you ask for a at 2, it's asking for the value of the function when t equals 2. And a at -3 is asking for the value of the function when t is -3. And again, you put a number in for t. In this case, that's -3, and you have to square it. You're squaring all of it. Both the negative and the 3 are in brackets because they're both squared. -3 times -3 is +9, and 9 take away 3 is 6. So there's your answer. Okay. Now, part C says, what is a at u? That's not a typo. Whatever's inside the bracket, we replace that into the variable in the equation. So a at u means that you're going to replace the t in the equation with whatever's inside the bracket. You're going to replace it with the letter u. So in this case, your answer is not a numerical answer, it's an expression. A at u means you're going to replace the t in the equation with the letter u. So instead of t squared take away 3, it's u squared take away 3. And then part D, we did one like this on the previous page. What is the value of t such that a at t equals 22? So again, the original equation is that a at t equals t squared minus 3. On the previous 3 questions, we were given a t value. A at 2 means what is the value when t is 2. A at -3 means what is the value when t is -3. Here, though, we're told that not what t is, we're told what a at t is. And a at t is the entire left side of the equation. That equals 22. We want to solve for t. We would do that by first adding 3 to both sides. So on the left side, 22 plus 3 is 25, and that'll be t squared. And then to find out what t is, we would take the square root of both sides. To get rid of the square on the t, we do the opposite squaring with the square rooting. Now what you have to realize here as well is that when you're solving an equation and you take the square root of both sides, there's always two answers. There's the positive root and the negative root. The square root of 25 is 5, but there's going to be two answers there, both plus and negative 5. They both will work in the equation. So let's do a check here. So a at t must be 22. So we did something similar to this at the start of the year when we did our review of solving equations. We checked our answers. And that's all we're doing here. A at t is 22. So first let's check when t is negative 5. Remember, you're squaring both the negative and the 5. Negative 5 times negative 5 is positive 25. Take away 3 is positive 22. So negative 5 works. Now let's check and make sure positive 5 works. And it does. Because positive 5 all squared is still 25. And 25 take away 3 gives us our 22. So they both check. When you're solving an equation and you take the square root of both sides, there's always going to be two answers, the positive and the negative root. Okay, so all functions are relations, but not all relations are functions. Remember, a relation is a function if no 2 points have the same x value. And so if you have a table of values or a set of ordered pair, you compare all the x values. If they're all different, then it's a function. Remember though, if you have a graph, we use that vertical line test. If you have points with the same x value, they'll be stacked directly on top of each other. And a vertical line will cross in more than one spot. So we use that vertical line test to see if a relation is a function or not. A relation is classified as a function if each value in the domain corresponds to exactly one value in the range. Again, another way of saying that is no 2 points have the same x value. Each function has its own formula or rule that is often given using a special notation called function notation. For example, p at x equals 2x plus 8. And the reason why the letter after the p, the letter in brackets is x, is because that's the letter in the equation. That'll always happen. Those two letters, those two variables will match. Normally we write f at x, but in reality it can be any letter except the one that's in the bracket. You can have p at x, you can have a at x, you can have t at x. It doesn't matter. But the letter in the bracket must match the letter in the equation. So again, it shows us that the function p takes an input value, whatever x is, it multiplies by 2 and adds 8 to get the output or the answer. Okay? So there's another assignment there, 6.3 and 6.4. This one is also due for marks. So there's 4 pages there. 2 pages back to back. You're going to rip them out. You're going to put your name on them and make sure you staple them together to hand it in. Pardon? Okay, so you can get working on that. So again, I think we just have one more lesson. I think we do 6.5 in one day. Pretty sure. Yeah. Oh no, 2 days. 2 days on 6.5. So that means Tuesday, Wednesday will be 6.5. Your quiz will be Thursday. That'll cover 6.3 and 6.5. Okay. Also, the students that were away Friday have to write their quiz.